Hi friends, so my name is Shyam Thakkar and I'm a practicing architect since 2006. We have a firm called B+D Architects and I did my architecture from Arjun School of Architecture in 2004, and then I did a training job as an intern architect for 1 year in Delhi, and then I left to US for my master's. So I am a professional urban designer, did my degree from Washington University in St. Louis, US, and since 2006 we are practicing. So let me start from a point wherein I was able to do one of my favorite projects. So while in college, I had a dream of designing an airport. So I took a thesis project of International Airport Transportation Hub at Indira Gandhi International Terminal. So friends, let me tell you something about the Jaipur International Airport Terminal, the expansion of it, which we designed recently last year. And the arrival has been commissioned and the departure expansion has shortly to be commissioned. Let me start from the initial problem, how we got the project and what was it like to work for such a good project. So, Jaipur International Airport is receiving lots of flights these days. So, shortly it became a short airport, which means that the passenger loads increased and the terminal building was getting shorter. So, the Airport Authority of India proposed an expansion of arrival and departure so that they can accommodate the load, but they didn't want it to add another aero bridge to it. So the development has had to be, slightly smaller in scale as compared to the existing building, and it had its own challenges also. As I think some of you might have seen the international airport, while most of you might not have seen the airport, it is kind of a curvilinear building. So my aim in designing the expansion of arrival and departure was to accommodate the existing design and to add to the existing terminal building in a way that it becomes an inherent part, yet it has its own identity. That was the thing where we started the problem. So let's start a basic sketch. What was in like the international airport building, which is right now. Let me draw you a couple of sketches. So this is the kind of building that is there. It has got, those who are familiar with Jaipur, we have Jawahar Circle. It's a big circle right next to the airport. So the center of this airport building lies somewhere in Jawahar Circle. The center of this building, as you can see, lies somewhere in Jawahar Circle. So we were supposed to do the expansion on this side and somewhat on this side. The taxiway, however, or the runway is like this, which means the landing and takeoff takes place in this part, and then the flight does taxiing like this and parks like this. Now, since we are supposed to do the expansion on these two sides, so let me tell you what is happening. Right now, the terminal building is somewhat like this. This side of the building is departure. This side is arrival, which means if you want to fly out of Jaipur, you would be somewhere in this part of the building. When you are checking in Jaipur, you are going to land or enter the premise of Jaipur in this part. And here we have got pylons and the canopy. So we were supposed to do the expansion in this part. Let me write it: future expansion, future expansion. Now, as you can see, the building form in this, it is slightly radial in form. And the expansion had to be done on the left and right, which means the arrival was supposed to come on the right side along the existing arrival, and the departure of the building was supposed to come on the left side, which is adjacent to the existing departure of the building. So this was the basic format, and that was the feedback. And we didn't have to add the aero bridges, though the aero bridges are located somewhere over here. Aero bridge basically is a platform wherein you can directly board the aircraft, and you don't need any bus to go towards the aircraft. So the aircraft comes and parks over here, and you can actually board the aircraft directly, maybe from this point and maybe from this point. So that's how it happens. So I hope you've got a basic plan which is getting clear to you, that what was the basic inputs. Now let me come down. This is just a planning explanation of it. Now the existing building, let me show you how the existing building in sectional format is, so that you can understand the topography of the building. This is the ground, then this side is the arrival, that means taxi drop off. Then the building is somewhat like this, and then you have the aero bridge which is standing over here. You have the ground floor level, you have 6 meters level, we call it 6 meters, and then you have the 10 meters level. So it is somewhat like this, the existing terminal, and then the aero bridge connects like this, and the aircraft parks somewhere in this point. So you board the aircraft like this. So now this is the existing setup of the terminal, and let me show you the actual plans of how the things are happening in the terminal right now. So friends, this is the architectural plan of it. As you can see, till this point is the existing terminal. As you can see in this, the arrows are marked. You enter the building from here, you have a security check, then you have the immigration officers, then you have the domestic lounge, and then either you get a bus pickup from here or you go up further for the actual departure or the immigrations. Then you have the arrival terminal, which is over here. There is this one belt, there is this second belt. So your luggage comes over here and you check out from this point. So this is the exit. Now the additional to the building had to be done in this area and in this area. This is the arrival part which we designed. So the arrival part which we designed had to have 3 belts, the carousel. So you can see the belts which are coming over here, and then you have the arrival porch. The bus has which used to come parked somewhere over here. So you get down, you enter the building, as you can see in the arrows, and then you have a toilet block. You come in, either you go out from here or you enter the main arrival and then you come out of here. So there were 2 possibilities. So we had designed it accordingly. Now coming to the departure. Departure is supposed to be in 3 levels. One is the 00 level, where we have the check-in counters, and above that we had 6 meters level, which further added to the main building, and we had a 10 meter level. In the 10 meter level, if you go directly, you were directly in a position of getting towards the security tunnel and then boarding the aircraft. So that is the basic knowledge which I wanted to give you about the entire terminal. Now comes the actual designing of the terminal. As you can see, this is approximately, let me start in fits only, because mostly people are comfortable while using fit as their dimensions. So this is around 71 meters, which turns out to be around 220 foot linear building, which was supposed to come. And this part, though it is not big, but this is around 25 meters. So the original objective was to make a hall in such a way that least interference is there. The structure was supposed to be designed in tubular framed structure. That means we were using box sections, metal box section, IS metal box sections, and developing the entire terminal. I had a philosophy of making a curvilinear building. So I wanted the span to be as much as open so that once the person arrives from here, he sees a long integral building which has least interference in it. So what I wanted to do was to make an absolute columnless building, but while using the tubular structure, we had a limitation that only 100 feet length could be achieved at a time. So let me come down to the sketch wherein I'll show you the concept which we did for developing the arrival. So as you can see, this is the existing terminal, like this. Now, my building was supposed to come in this area. What I did was, somehow when you land from the air, you always like to see a curvilinear or a fluidic building because that gives a better impact. Now, in this particular case, I didn't have a liberty of designing to what I wanted, the curves the way I wanted, because we had an existing structure. So I took the formation of existing structure and I wanted to create a separate identity of my building as well. So how can we do that? So we took this formation, and since the height was not supposed to be that high, so I did two interventions. Option 1 was a fluidic building, like this. But then this had a disadvantage, a very practical disadvantage, which Airport Authority of India told me. Once it rains, we have two collection systems. One, the water would come down and fall from here, while the other, the water would come down in the center of the building and the water would drip like this. That was a practical problem. That water might collect over here and the building has to be in a metal, so it might start seeping from this point, and nobody wants to see a dripping airport. So what we did was, we took different formation and we curved the building like that, like this, and then we had a small arrival canopy, and on the other side, since we had a pylon system,
सर पेपर पीछे चला गया बहुत.
So this was the taxi area, taxi parking area. This was the main arrival, and here was the airport plane taxiway. So this curve we designed in such a way, the existing curve, as you can see, is somewhat like this. Sort of a single side curve. In this case, the water falls over here and it is collected on single point like this. And in our case of design, we did the building like this. The water falls here and you have a collection which is happening over here, and then you have a collection which is happening here, and it drips out like this. So this is the basic concept of the building which we designed. Now that the same case was in departure also, we had to maintain the same trajectory. So that is what we did, but we'll come to the departure in second level. Let me tell you one more thing. This is a huge structure, and the beams, the girders were almost 1.2 meter, that is 4 feet deep at both the ends. So if this is a huge curve, and this is called the tangent. So in this part, this particular curve behave like a straight line. What I did was, I actually managed the length around 40 feet, which is approximately the length of an individual box section. And we used straight lines like this and divided the entire curve into straight lines. So that was the basic engineering technique we had to use in this building, rather than making a single curvilinear structure, which was, had a technical limitation sitting in Jaipur and considering the cost constraints of Airport Authority of India. So as you can see in the structure, you might feel like this is pretty straight. But actually it is not. We have used different tangential sections and placed it accordingly. So coming to the other image of it, as you can see, this is during the completion of it. As you can see, the curve is starting to get obvious, and as you can see, the depth, immense depth of 220 feet, with a single column span, around 100 feet of depth with a single column. So that's how we conceived this building. Now the other challenges was to incorporate the other services which are very important in airport buildings, namely the HVAC, the air conditioning, the use of glass facade. The existing building had a glass facade, and we had to integrate that glass facade in this building. It had a special character. So let me come to the plan of arrival. So this is the final arrival plan. As you can see, we have the entry over here from the taxiway and an exit over here to the main building. Somewhere over here is the main building. And from here, the person who comes out of the flight enters the building. So this is the arrival porch. You have a covered canopy. You have the AHU rooms on both the sides to keep the building cool. AHU rooms are air handling units that is used for HVAC purposes. And then you have another glass fascia, the glass curtain wall over here. So this is basically the arrival porch. You enter the building over here. And then you have belt number 1, belt number 2, and belt number 3, wherein you can take your luggages. And this is a toilet block for the facility. And we had, provided some of the concessioners. So if you are coming out and you want to take flowers for your girlfriend while you're coming out, you can always do that from these concessioners. And then, how does your luggage comes in? So a tractor trolley or maybe anything will bring down your luggage, drop to the respective belt, and the luggage comes over here, and the belt rotate like this. And then you can stand around and you can collect your luggage from here. Then you come out. We have a small visitor area as well, wherein if your girlfriend or if your friend is coming, they can come in, stand over here to meet and greet you, and we have a small kiosk counters over here, and then you come out and then you go. So this is the actual architectural plan of it. Now coming to the detailing of it, the most important character, as you must have seen in my previous sketches, the roof was curvilinear to accommodate the ceiling. Ceiling in this particular case, we had taken Armstrong metal ceiling, and this was a curvilinear building. As you can see in the plan, let me put it in the same way. This is a curve. This building has two curves basically. One is in the plan, so it is radiating like this, and one is in the section. So that is very crucial. When you design these kind of building, the false ceiling becomes a very tedious element, But again, there was a cost constraint. So we, however, managed to use this ceiling, but to do it in a curvilinear format was getting very expensive. Again, we had to use that tangential technique in the ceiling also. And we actually developed an indigenous way, our own way of ceiling detailing, which I'll show you in further coming drawings. So these are 600 by 1200 mm ceilings. So 600 by 1200 is 2 feet by 4 feet ceiling. So we did 600 by 1200 ceilings after every 2 blocks, since the curve was radiating, so the building was changing its dimensions. So we started to do the ceiling from the center. As you can see in the center, this, and it keeps on rotating. But since the grid had to be kept straight, so entire difference had to be taken out in the center. As you can see, the last grid, it keeps on changing its formation. So we had to actually cut the tiles while placing them on both the corners. Like this. So the laying of the grid had to be started from the center, right from the center of the main axis, which is this one in this case, and the building center, which is this one in this case. Again, we broke the tangents. So one tangent was this one, so the ceiling went straight and then changed its curve. So this one was flat ceiling, again this one was flat ceiling. So coming back to this particular curve, so you can see in this case we further took down the straight line. So this was the straight line of the ceiling, this was again the straight line of the ceiling. So while doing it, actually we created like this. That way we reduced the construction cost almost to 50%. But when you are standing over here and you look at the ceiling, the span being 220 feet, it appears to be curved, but actually it is not. So you save a lot of money while doing that. So that was the concept. Now the other challenge was to embed the air conditioning. As you can see in this particular line, you can see the ducts running. So this is first HU. So this duct, as you can see, is coming over here. It keeps on reducing and it comes till the end. Same is the case in this ducting. So the ducts start from here. It keeps on coming like this up till the end, so that the ambient cooling is same throughout. Now again the problem was the curve. In this case, as you can see, the curve was there, so we had to keep the ducting again in that tangential aspect. So this is how we place the duct. And the grill, again the grill can't be curved, so we took 10 feet grill pieces and we placed them in the tangent. So the grills were straight, but while arranging them, they look like a giant curve. So as you can see in this, we had a linear pattern of diffusers from which the air comes out. This one, this one, this one, this one. And here we had alternate grid pattern, actually, the grill pattern. Here we do the throw and here we collect. In the same case, here we do the throw, here we collect. Here we do the throw and here we collect. So that is, a complete cycle. In HVAC, we have to maintain this cycle in order to keep the temperature of the air less. Then comes another important part. This ceiling had to be insulated in order to reduce the heat load. So how do we do that? So the metal structure, this maybe, as you can see, the truss. And in the top, we did the layering of glass wool and heat insulators. Okay. So this is the main section. And you can see the metal structure going like this. And in this building, this is a transverse section, as you can see the ceiling over here. And we have this truss coming. We have the glass box section and the ceiling on top of it. And this is the glass facade. I'll come back to the glass facade very soon. And this is how we executed it, the ceiling. We had this L flushing with 0.5 mm thick galvanum sheet and the heat insulators, and then the main box section. And this is how the curtain walls comes in. Now this is the external facade from this carousel side. It is somewhat like this. So we have these luggage belt, one belt, the second belt, and the third belt, which goes around and which collects the luggage. So to give that kind of perforations, we did a 3 meter high wall, and above that, this was actually, this was which direction? This was actually the south direction. So we had to use a double glass unit to reduce the heat load. So in this case, what we did was we used a double glass unit in south side and in the west side to reduce the heat load. Now in this particular section, you can see how the double glass unit fits in. Double glass unit is a special unit wherein we give a air gap and put two types of glass. The outer glass generally is the heat reflective glass or transparent glass. The inner glass is generally a transparent glass in this case. So that is the basic structure of it. So friends, now I'm going to explain you the facade of this building. It is very important to design this kind of complicated facade. So let's do one thing before giving you the design of it. Let me explain you the sketch of it. In this particular case, what happens is, on one side, as you can see, the height of the building. So this is the truss which is coming, which is around 1500 mm or 5 feet. And then you have this big, there is a base plate in it. And then you have the main column, which is around 1 meters. And we have to cover this entire setup. And the building continues further. As you can see over here, this is the pillar, this is the glass. As you can see, there is a metal structure behind it. And then we have a ACP wrapping. And if you see the front facade of it, one more thing, this is the ACP wrapping and this is the main column. Now comes the important thing, which is putting the glass facade. So this is the main structure of the building. The glass facade has to come out of the building. So let's make the glass facade. So first, this is approximately 5 meters. And this is approximately 6.5 meters. We have to cover this entire thing. So how do we do that? So in case of front elevation, we need to put glass. But this is main part of the structure and this expands in a different ratio. We can't put the actual glass facade onto it. So what do? We create a separate element of the entire glass facade. So at a small distance, what we do is, this is how the glass facade would come in. But we will have to maintain a distance from the main structure. How do we do that? That is how we do. This is the column. This is the main structure. Now, in front of the main structure, we introduce another facade element, another structural element. And we connect them. Let me make a fresh sketch as this has become a little untidy. First make the fascia on which the facade would stand. this, and they are connected. These are all box sections basically, all right. So at every 1.2 meters we give support to these, and this gives, because this is approximately 7 meters high, and this has to be given lateral strength as well. So this continues. So this is this one element, then comes the other element, then comes the other element. So this thing is inside and this is outside. Now this joins like this with horizontal elements, like this, like this, and to maintain a slenderness ratio, we provide a rear support like this. So once we do that, this stabilizes, and this is further stabilized by horizontal elements, and further they are connected like this. And then, since this is 1.2 meters, we start placing 2.4 meter glass. So this becomes one of the glass panels. This becomes a glass panel. So the glass, if you studied about the glass generally comes in a module of 1.2 meters by 2.4 meters. That is 4 feet by 8 feet. So this becomes one glass panel. Then what do? We have put these glass panels, and we are getting support at every 1.2 meters. So we put the spider fitting, and these spider fitting are supported on the metal structure. Alright, slightly tedious drawing, but then that is what the architecture is all about. Now let's come to this sketch. This is the main column, as I told you previously. It is supported with a huge foundation which is coming at the bottom, and then again a foundation for our external glass facade. So this entire thing, let me use a different color pen. This entire is the metal structure, and this particular thing, this particular element, let me show you the plan. Is coming over here. One is over here, one is over here, and it is happening over here. So these are the main structural elements, and in the center we have these structural elements which are coming over here. So the entire structure, it spans like this. I think you must be getting the understanding of the structure now. So that's how it continues. So these are the main structural elements, and in the center we have provided the support to the structure, so that gives you a span of almost 110 feet here and 110 feet here. Okay. Now coming back to the steel element of it, the external glazing. So this entire element is a straight member which supports the glass. This is the glass, as I told you, and this is the spider fitting. Alright, so that is how we fix the main structural element with the external structural element and the glass above it. And as you can see, this particular profile, this is the ACP fitting, and this is the actual covering of the terminal building. So this is the glass covering, this is the roof covering, and this is the roof element. On top we have 0.5 mm galvanum sheet, and then we have heat insulations of glass wool, and then again we have a metal sheet that is basically a sort of a sandwich panel, we call it, and then we have the main structural purlins, and then we have the main rafter. So that is the entire structure, how it sets. And this is, as you can see, we have given a gap between ACP and the roof. This is provided because the water is going to fall like this, and it will flow like this. It will be collected into this drain over here, gutter, we call it gutter. And then the water drifts from the gutter to the underground piping system and it comes out. Now this particular section is of the airside canopy. So we have two things. One, the water is falling over here, and one, the water is falling on this canopy right over here. So we have two collection points for water. One is the top. In the top, the water collects. It goes into this, artificial facade which we have created, and it goes inside the gutter. And the water which falls over here, it comes down over this point, and there's again a small gutter which we have provided. Water comes in this and get collected into the main pipe, and it goes down. So that's how we take care of the extreme rainwater which falls, because if the rain is falling with a speed of 1 inch in 1 hour, it will be a huge water collection. So we had actually designed the entire pipe on the basis of that calculation for the extreme rain loads, so that it doesn't fall short and the water doesn't overflow. So that's about it. So let me show you the final outcome. The curvilinear effect which is coming in the building. Though it is not curvilinear, as I told you, it is a tangential straight line structure. Okay, so I'll not take a further more time because the technical aspects have been covered. I'll just give you a glimpse of departure, and we will culminate the entire discussion. This is the meaning of the arrival we have already done. So let me show you how the departure sits in. So this is again the existing terminal building, and here we will be connecting the departure as I showed you in the sketch previously. This is here you enter inside the building, then you have the check-in counters, then you have the staircase as well as the escalators and a lift in case we need it, and then we have a ramp which is taking to the upper levels. Although the staircase and the lifts are taking to the upper level, but this particular was available before the expansion, so we actually covered it. And this was a 0 meter level, as I had explained you further, and this is the 6 meter level. This plan at 6 meter level, where you can see the concessionaires, the shops, and the connection to the main terminal. And then I'll show you 10.5 meter level plan. So this is the 10.5 meter level plan. In the 10.5 meter level, we just have the connection to the security hold and international departures. So in this particular way, the connected departure can serve to the international departures, the domestic departures, any ways it can be used. I'll briefly run through the RCP plan, as again in this particular case also the RCP plan is very critical. Again, the building, as you can see in this, is radial. So we have this straight line, but the building, as I told you before, has a center in Jawahar circle somewhere. So this diverges. So this line converge to to a center point somewhere near the Jawahar circle, and this is the end point of it. So in this particular case, the ceiling, we started from one end because the building is changing its formation. The building in the first area ends over here and it continues. So we didn't want it that in smaller gap the cutouts would appear as in case of arrival. So we started from one end, we did it, brought the differences at this end and continued this structure further so that all the differences of the ceiling could be taken out this end. I hope you understand my point. Okay, so that was much about the ceiling. I'll show you a lateral section, a longitudinal section of it. So this is the city side and this is the air side. And in between, as you can see, we have a bus drop-off which is connected further. So here you can see the counters, check-in counters. This again is the glass structure. This is the metal structure, the metal column structure. This is again the truss we are talking about. And this is again the same profile we are maintaining throughout the terminal building. And then these are the concessionaires which I had shown you. And this is the ceiling details which we had incorporated in the terminal. Here you can see one more thing which is very important. This is the 6-meter level. The staircase goes up to 10-meter level. And this is the ramp which is connecting the entire area. This is the concessionaires area. And that is how the building trajectory is. Again, in this particular case, the ceiling was very important. So we again used the tangential. As you can see, the ceiling is divided in every 12 meters. So for 12 meters, the ceiling runs straight in a curve, in a tapered format like this. And then it changes its trajectory slightly over here. So these are the axiom connection points. So what axiom helps is, it changes the trajectory. As you can see in this is 12 meter long, and then you put an axiom over here. You again put axiom on a slightly different angle which is needed, and so that it changes the curve trajectory. I hope you understand it. So at every 12 meters, we put axioms and we change the trajectory of the curve as needed. So that way you make this straight profile to appear as a curve. So that is quite an interesting engineering technique which we used to reduce the cost of the structure. I hope it is very much clear to you. That's how it is. Let me show you the side elevation of it. This is the side elevation. As you can see, the ACP coming in, and then the double glass unit facade coming in, and then the bus drop off, and then the overbridge. Further on are the Aero Bridges. So this is how it looks from the air side. This is the airside facade. Let me show you a couple of images and then we are going to close up with our presentation. Friends, this is pretty much what I wanted to explain you about the airport design. I hope you would be able to get quite a good understanding, and for the students who would like to do thesis upon the airport, you would be able to understand the basic functionality of airport and how a building is to be extended and how the circulation takes place, what are the check-in counters, how does the arrival terminal works. So I think you must be getting a very clear picture. And for the young professionals, budding professionals, I have tried to give you a basic idea of how the air conditioning is added to the building, or how the curtain glazing facade actually works. I tried my level best, but we have time constraints, so we will culminate the video here. And let me wish you best of luck for your future endeavors, and we will be further posting on a couple of more videos to give you different kind of understanding for the architecture. Thank you friends. Thank you very much.